Today we are going to start from lesson 13 of our Machine Learning 101 lecture series, and today we are going to be talking about classification. So classification is the second aspect of supervised learning, because we mentioned that under supervised learning we have classification, we have regression. We've discussed regression in the previous classes, and today we are going to be focusing on classification. And one thing about classification is if you follow the regression classes, then you find out that classification is really very easy to follow, because kind of classification is a modified kind of regression. So classification becomes regression at some point, and we are going to see what this is all about. So let's get to the screen and continue working. So the first thing we are going to mention here is that in classification we also have a data set. So we have data set X and we have data set X and Y. So the difference is, well, of course I mentioned this here, in case of classification we have a data set made up of X and Y, but now the values of Y are discrete or categorical. Let me give you an example of what we mean by the values of Y are discrete or categorical. Let's take, for instance, we have, let me take a better pen. Okay, just give a second. Change the size to something like this. Okay, let's say we have X and we have Y. So typical data set, regression data set, we may have 1, 2, 4, 6, 7, and here we have 3.6, 4.2, we have 8.9, and so on and so forth. So this is a typical classification problem, but in a typical regression problem, but in case of classification we have X and we have Y. So you need to notice the difference, how the data set differs. While you have the same X value, now the data, the Y part of it is now categorical. So you may have something like 1, 2, 2, 1, 1. So in this case you have two classes. So we can say this is C1, this is C2, this is C2, this is C1, this is C2. So it means that for each value of Y, X you have, you need to classify it under a particular class. So what we call the Y variable is, we call it classes or target classes, right? Good. So that is the difference between classification and regression. And this kind of variable that values that Y take is called discrete. They are discrete values. It can either be something or the other. Another difference between classification and regression is that in classification we have to measure the error rate. In regression we have to measure the mean squared error. So I'm going to write it down. So this is classification and regression. So it's better you know the difference between classification and regression. So in classification we have the data type is discrete. In regression is continuous. In classification we measure the error rates. In regression we measure the mean squared error. Okay, so take note of these differences because we are now going to be making use of it. Now what happens in both classification and regression is that when you are given a new data point, let's say in this case, let's say we are given 9 and we are told to predict the class it belongs. Will it be in C1 or will it be in class C2? That is what we want to do in case of classification. Now for us to do this, for sure we need a model that can take this value of 9 and classify it into C1 and C2. But before we talk about this model, let's talk about the error rate. The error rate simply means the proportion of misclassifications that you do. For instance, we have two classes C1 and C2. Let's call this Y. Okay, let's call it X and Y. So we have, if let's say we have Xi and we need to classify it into Yi, right? So an error occurs when we have a model f of xi is equal to yi. So we classify this xi to belong to yi, this yi cap. And we are saying that yi cap should be approximately yi because we did the classification fairly good enough. But there is some error that is introduced, meaning that yi is not equal to y cap of I, meaning that we misclassified. So in this case, we are going to count all the misclassifications and then we take the average of all these misclassifications. So what it means is that we have this formula to be 1 over n. I is equal to 1 to n. We use an indicator random variable to count when yi is not equal to f of xi. So what we are saying is that anytime we classify xi and the value is not equal to yi, even if it's close to it, we have misclassified. Because in this case, even if it's close to it, we misclassified. It has to be either we classified it correctly or we classified it wrongly. We can't approximate in case of classification. So let me put it as a difference. In classification, can't approximate, but in regression you can approximate. So we are saying that the value of I is counting every time that we misclassified. So at the end of the day, the total number of misclassification over total number classified. So we have total misclassification over total classified. So that means that if we classify 100 items and we misclassified 5 of them, we'll be having an error rate of 5 over 100. Okay? So take note of that. We are talking about the error rate. Okay, so let's see. So in this case, I can also mention that if you have two classes of 1 and 0, that becomes something called logistic regression or binary classifier. We are going to talk about this a little later. So when we have a model, this model f of xi, that helps us do the classification, then we can apply this model on the training data set and then compute the error rate. Okay, so the test error rate for a set of test data of the form x0, y0 is given by this, of which we've mentioned this is about the same as this, the average error rate, where y0 is the predicted class level using our classifier, and as before, the objective is to minimize the error rate. So it's the same objective as in classification, the same in regression. We want to minimize the mean squared error, and in classification we want to minimize the error rate. Let's now take an example of classification, and since I have a little time left, I'm going to stop here, and in the next class, which will be 13A, we now discuss a particular example of classification in case of classifying cancer patients. I'd like to thank you for viewing. Remember to subscribe to my channel and also like this video if it's been informative for you.